Hey guys, welcome back. We are going to go through an Algebra 2 semester exam study guide together. So let's go ahead and get started. I do have them categorized into specific categories, so you will see those at the top, and there's a few questions of each type. Okay, so write the equation of the line that passes through 6, 3, and 4, 7. First thing that we have to do is find the slope. The slope is going to be y2 minus y1 over x2 minus x1. So I like to label my points x1, y1, x2, y2, and then we're just going to plug them in. So we're going to have 7 minus 3 over 4 minus 6. That's going to be 4 over negative 2, so our slope is negative 2. Now, depending on how your teacher prefers it or what the instructions say, you could write it in y equals mx plus b form, or we can just use point slope form. That's going to look like this. Then you just plug in either point. I'll go ahead and plug in the first point since I labeled that one, x1, y1. We're going to fill in our slope here for negative 2 for m, and then we're going to do x minus 6. And this is technically an appropriate answer for this. If you have to put it into slope-intercept form, you can also do that by distributing this 2 to both terms and then adding over the 3, and that'll get it in slope-intercept form. Or standard form, same thing, you would just have to rewrite it, distribute that negative 2 and rewrite it in the standard format. Okay, write the equation of the line that has an undefined slope and passes through negative 5, 2. So undefined slope is a key word here. Whenever you have an undefined slope, it's going to be x equal to some number. Now, since we have a point that goes through negative 5, 2, our x value is negative 5. So our answer for this line is x equals negative 5. Just to recap, that's what this graph would look like. You would go 1, 2, 3, 4, 5. It would be a straight up and down line. That's defined as having an undefined slope. Find the slope of a line parallel to 6x plus 7y equals 42. First, we have to, again, find the slope, and we're given an equation of a line, so that means that we need to get this into y equals mx plus b and identify what the slope is going to be. So in other words, solve for y. So let's subtract 6x from both sides of the equation. So we'll get 7y equals negative 6x plus 42. Next, we're going to divide everything by 7. Now, the only thing that we are really concerned about is right here, our negative 6 over 7. That's going to be our slope. Now, and then the line that is parallel to that is going to have the same slope. So the way that I like to write this looks like this. You have parallel slope, and that's going to be negative 6 over 7. Number 4, write a line perpendicular to 5x plus 2y equals 16. We have to do something similar here. We need to still solve this equation for y, and then we're going to extract the slope from that. So let's go ahead and subtract 5x from both sides. Now we're going to divide everything by 2. So again, we're only concerned about this slope here for the perpendicular line. So our regular slope is going to be negative 5 halves. That means our perpendicular slope is going to be the negative reciprocal, which is going to be positive 2/5. Now we don't have to focus on this equation at all anymore or this slope anymore. Totally irrelevant. Now we need to write a line that's perpendicular to it, which means that it can intersect anywhere along the line. So now all we have to do is find an equation, y equals 2/5 x plus b. This line right here intercepts the y-axis at 8, so we can use 8 for our b if we want, but we don't have to. We can pick any b value that we want. And that is the equation of a line that is perpendicular to the one that's given. Number 5, a laborer's pay varies directly with the hours worked. If a laborer makes $75 for 5 hours of work, how much will he make for 15 hours of work? So varying directly, that means that it's going to be y equals kx. So that would mean that this is the laborer's pay, and x would be the hours worked. This is just a constant term that allows it to vary directly. So if we know that he made $75 for 5 hours of work, we can go ahead and plug that in, divide both sides by 5, so we know that k is 15. Now, how much will he make for 15 hours of work? So it would be y equals 15 times 15. So it's going to be $225. Number 6, graph y equals negative 2x minus 4. It's a little bit hard to see on the screen here, but I do have graph paper here. But let's just go ahead and draw our x and y axis. Now we're starting our y-intercept at negative 4. And from that point, we are going to go down 2 to the right 1. So we're going to plot our second point right here. Now all that we have to do is connect our dots. And we'll do it as best we can. But it's going to look something like that. Number 7, graph the inequality 3x minus 2y is less than or equal to 6. First, we have to solve for y here. So we're going to subtract 3x from both sides. So we have negative 2y is less than or equal to negative 3x plus 6. Now we're going to divide everything by negative 2. Remember that when we divide by a negative, we do have to flip this sign. So this is going to be y is greater than or equal to positive 3 halves x minus 3. So that's what we're going to focus on graphing. Okay, I'm going to go ahead and sketch our x and y axis here. So we're going to start on our y-axis at negative 3. Then from that point, we're going to go up 3 and to the right 2. So this is where we're going to plot our second point. Now we have to focus on this inequality symbol. Since it is greater than or equal to, our line is going to be solid. I'm going to adjust this a little bit. Okay. Now, I want to show you guys a trick that has really helped me and my students understand where to shade. Basically, what you can do is you can cross off this portion just for a minute. And you want to look at the y-axis and find out where the values are greater than or equal to negative 3. So if negative 3 is here, are the values up here or down here greater than negative 3? Negative 2, negative 1, 0, 1, and so forth are all greater than negative 3. So we are going to shade above the line. And this part you can just kind of sketch. And that's our answer. What that means is that any point within this region, and in this case along this line, will be a solution to that inequality. What would the domain and range be for the following piecewise function? Okay, now we are heading into functions and systems here. So this piecewise function, it really looks like this. This is probably the more familiar way that you would see it written. You'd probably see it stacked. Now, both of these equations are lines. And how we know that is that they're in the format of y equals mx plus b. Well, the domain and range of lines is always going to be all real numbers, unless there is some weird restraint. Now, this function here, okay, it says that this graph exists everywhere that x is less than 2, and this graph exists everywhere from 2 and up. So there is no point in which our graph does not have an x value that works for it. So in this case, the domain is all real numbers, and the range is also all real numbers. Number 9, write a function for the data given. So this is kind of a trick question because a function requires there to be one x value for every y value. And here we have many, many repeated x's. We have a 1 repeated here. We have a 2 repeated here. We've got a 4 repeated. And we also have a 3 repeated. So literally every x value has a double y value, so this one is not possible. You can graph a relation, but there's no way to write a function because it does not pass the vertical line test. Number 10, how is the graph y equals absolute value of x minus 3 plus 4 different from the parent function? So this parent function is going to be y equals the absolute value of x, because that's the function that it looks most like. Now, from our parent function, there is no horizontal shift because there's nothing else within our grouping symbols, and there's no vertical shift because there's nothing outside of our grouping symbols. So in this case, the way that it differs is that our translated graph up here has a shift to the right 3 and up 4. So that's the difference between it and the parent function. Number 11, graph y is less than the absolute value of x minus 2. So in order to graph this, we're going to, just for the sake of getting some points on there, say y equals the absolute value of x minus 2. So this is the absolute value graph shifted to the right 2 units. And if you're unfamiliar with the parent function, what you can always do is plot points. Okay, so this is what the parent function is going to look like. And I'm going to go ahead and sketch it. Now, what the translated graph looks like is it is shifted to the right 2 units. So this is what it's going to look like here. Now we need to focus on graphing this. So where we are going to shade it is where the y values are less than our graph, where they are underneath. Okay, so the y values are going to be smallest below the graph. It's going to be here, everywhere below it. So any point and shaded in yellow will be a solution to this inequality. Now I realized something. We forgot to look at this point, or excuse me, this inequality symbol. It is strictly less than, so we do need to change our line here. Let me see if I can do that. 1 second. Okay, so there we go. I have adjusted that so that we now have a dashed line. So anywhere underneath this graph would be the solution to the equation, but you cannot pick any point that falls exactly on the line because that will not work. So hopefully that's helpful. Number 12, solve the system using any method. Here we can see that we have our positive 4y and our negative 4y. And so I would suggest using elimination here. We are just going to stack these down and add straight down. Our y's are going to cancel, and then we're going to divide both sides by 6, so x is 4. Now to find out the corresponding y value, all we have to do is plug in this answer into either equation. It doesn't matter which one. Now we're going to subtract 8 and then divide by -4. So the solution to our equation here is going to be 4, -1. And in other words, that is where our lines will connect on the graph. Number 13, graph the linear system. Okay, I'm going to go ahead and sketch our x and y axis again here. And we do need to solve these equations for y first. So I'm going to add y on the top one and subtract 3. So this is going to become 2x minus 3 equals y. And for the second one, we'll go ahead and move our 2x. And then divide by 3. So our second equation is going to become y equals -2/3 x plus 4. Okay, we're going to graph this one and this one. Our y-intercept for the first one is -3. So we're going to plot our point there. Our slope is 2/1. So we're going to go up 2 to the right 1 and plot our point there. That's 1. Now our second equation has a y-intercept at 4. Then our slope is -2/3. So that's going to be our point over here. And this is how our graph is going to look. Okay. This may not be super exact, but it is just asking us to graph it. So your intersection point should be somewhere in the first quadrant. And if it were to ask you for the solution, then it would be talking about this point right here. But it doesn't, it just asks you to graph it. Number 14, use the elimination method to solve the system. So this one is requesting that we are using a specific method. I'm going to target our y values here because they have opposite signs. So here I'm going to multiply the entire top equation by 3. And that's going to give us 9x plus 3y equals -12. On the bottom, we have 2x minus 3y equals 2. When we add these together, we're going to get 11x equals -10 here. Okay. Then we're going to divide by 11 and get x equals -10/11. Now, in order to solve for the y value, we're going to go back and plug that in. And again, we can plug it into either equation. It's not going to matter. So now we have -30/11 plus y equals -4. So we're going to add 30/11 to both sides to get y equals. Now we need to get a common denominator here, so we'll get -44/11 plus 30/11, which is going to be -14/11. So our solution to this system of equations is going to be -10/11, -14/11. Number 15, sketch the graph of the system of inequalities. In order to start this, we do have to go ahead and solve both of these inequalities for y. And you can see that this second equation here, or the second inequality, is all divisible by 2. So let's simplify that first. Now, if we go ahead and subtract x, and then divide by -1, That's going to leave us with y is greater than or equal to x plus 1. Don't forget that when we divide an inequality by a negative, we do need to go ahead and flip that sign. Now let's do the next one. So if we go ahead and subtract 2x from both sides, and then divide by 3, we're going to get y is greater than or equal to negative 2/3 x plus 2. So these are the two inequalities that we are going to focus on graphing. Both of them have an equal sign there, so they're going to be solid lines. I'm going to go ahead and graph this one in pink, and I'm going to graph this one in blue. Our y-intercept of this equation is a 1. So let me just sketch in our lines here. Positive 1 is going to be right here. And then our slope is also up 1 over 1. And we get that from the coefficient of x. Since there's not one written there, it is just going to be up 1 over 1. Now we need to connect these dots. And like I mentioned before, it is a solid line. If it were strictly greater than or less than, then we would need to do a dashed line. We'll focus on the shading in a second. Now for the other one, our y-intercept is 2 and our slope is negative 2/3. So from this point, we're going to go down 2 and then to the right 3 and plot our point there. Again, this is a solid line, so we are going to go ahead and connect the dots with a solid line. Now we can go ahead and shade. So the way that I like to do this is actually to cover up this first part because it's not relevant when we're shading. Okay, what we're asking ourselves for the blue line is where is y greater than or equal to 1? Y is greater than or equal to 1 above the line. So we are going to shade everywhere to the top. When we have a system of inequalities, we are looking for the overlapping shading. So that's our first one. Now for the second one, we are looking for where y is less than or equal to 2. And that's going to occur down here. So we're going to shade everywhere underneath of our pink line. I like to use contrasting colors here when I'm shading so that it's easier to see where they actually overlap. If you use colors that are too close together, it's going to be kind of hard to see the difference in the shading. So you can see the system of inequalities solution is in this triangular portion right here. So any point here would satisfy both inequalities. And that's your final answer. Number 16. Now we're going into quadratics. Graph the function f of x equals negative 3x squared plus 5 and state the domain, range, vertex, and whether it has a maximum or a minimum. So graphing this, okay, we can do a couple of things. We can either plot points or we can go with the parent function and apply all the transformations. I think that I would prefer to go ahead and do a series of points. I always start with the vertex. The vertex can be found at negative b over 2a. Since we don't have a b value here, in other words, there is no just plain x value, it's going to be 0 over 2 times negative 3, which is just 0. Then, when we plug 0 back in to get y, this x would be a 0, which means that our y value would be 5. Now, what that means is that there is no horizontal translation, and our vertex is going to occur at 0, 5. What I'm going to do is pick 2 points on either side of 0, And what happens is that these are actually going to be the same value because we have a symmetrical graph. So when I plug in 1 for x, okay, what we're doing is replacing this value right here, x, with this value here. I'm also going to do that with 2. So when we plug in 1 there, we're going to get -3 times 1 squared, which is still 1. So -3 plus 5 is going to be 2. Because these are the same, we can go ahead and write that value there. Okay, so -1, 2 is here, and 1, 2 is here. Now when we plug in 2, 2 squared, that's going to be 4. 4 times -3 is going to be -12. -12 plus 5 is going to be -7. So we can go over to 2 and down to -7, and then -2, -7. So this is what our graph is going to look like. It's a much skinnier version. Yikes, that did not work the way I wanted it to. Here we go. It's a much skinnier version of our parent function of a parabola. Now, the vertex here is going to be 0, 5. Okay, we've already established that part. Now, looking at the domain occurs everywhere where x is satisfied for the function. So we're going to look along this line and see if there are any points at which our x value does not work for the function. And in this case, every intersection of our x-axis will result in a y value. And that means that the domain is going to be all real numbers. Now for range, we're going to actually be looking this way and seeing where our values stop existing. So you can see right up here, this is the last part, y equals 5, and our graph does not exist up here. So our range is going to be y is less than or equal to 5, or -infinity to 5. Okay, and then this is a maximum because it is a downward facing graph. Number 17, what is the quadratic model for the following set of values? So our quadratic equation is going to look like this. Okay, this is vertex form. We could also do this in standard form. However, doing it in standard form, well, actually, I guess it doesn't really matter. We can do either one of these. Now, in this case, because we have this 0, -2 here, I do think it is going to be easier to use standard form. So let's go ahead and plug in our x value here for both of these. And then we're also going to plug in our y value right here. That's going to yield -2. These both are going to cancel out. So we're going to get a direct result of C there. So now we have y equals ax squared plus bx minus 2. And we can go ahead and create a system of equations with the other 2 points. So we're going to plug in -1 and -11 for x and y respectively. Then we're going to plug in 1 and 1 for x and y respectively. Then create a system of equations and do either substitution or elimination. So for the first point, we're going to have -11 equals a times -1 squared plus b times -1. For the second equation, a minus 2. There we go. So to carry that down. Okay, for the second equation, we're going to have 1 equals a times 1 squared plus b times 1 minus 2. Now we're going to solve these independently. -1 squared is 1 times a is just a. -1 times b is minus b. -2 is there along for the ride. Add 2 to both sides. So then we get a minus b equals negative 9. Okay, that's our first equation that we're going to deal with. Now we're going to have 1 equals a plus b minus 2. We add 2 to both sides, so now we're going to get 3 equals a plus b. This is the second equation that we're going to deal with. Now we can look at these and see that elimination is probably going to be easiest because we do have opposite signs for b and the same coefficients. So if we do a minus b equals negative 9 and a plus b equals 3, if we add these straight down, we're going to get 2a equals negative 6. So then a is negative 3. From there, all we have to do is substitute that back in either here or here to solve for b. So 3 equals negative 3 plus b. Add 3 to both sides, so b is 6. Our final equation, because we now have a, b, and c, is going to look like this. We're going to replace all of our a's, b's, and c's with the coefficients that we got. So this is our final answer right here. Okay, number 18, find the vertex of the following function. This is already in the format of a times x minus h squared minus k, or plus k, excuse me. So I'll say that again and write it down. So y equals a times x minus h squared plus k. Because we have a positive 2 here, what that means is that a negative 2 was plugged into the function. So our x value of our vertex is going to be negative 2, and then our y value of our vertex is just going to be 10. So the vertex is negative 2, negative 10. List all the ways the parent function y equals x squared will be transformed to create the function y equals negative times the quantity x minus 1 squared minus 5. From this graph here, or from this equation, we do have a negative out front for our transformed graph. That's going to be a reflection about the x-axis. The second transformation is going to be this minus 1 inside. That's going to be a shift to the right 1. The more technical way to say that is a horizontal translation, right 1. The last transformation that we have for our transformed function is this minus 5, and that's going to be a vertical translation down 5. Find the vertex of the graph y equals negative 3x squared plus 6x minus 5. The vertex is going to be this formula, x equals negative b over 2a. Our b is 6, and the negative is built into the formula, and our a is negative 3. So here we're going to have negative 6 over negative 6, which is positive 1. Now, in order to find the y value of our vertex, we have to go back and plug in this value everywhere that there is an x in our function. So we have negative 3 times 1 squared plus 6 times 1 minus 5. This is going to be y equals negative 3 plus 6 minus 5, or negative 2. So the final coordinates for our vertex are going to be 1, negative 2. Complex numbers, number 21. Simplify the expression 6i plus 2 minus 4i minus 1. We're going to distribute this negative to both terms. So we're going to have 6i minus 4i Then we're going to have positive 2 plus 1. That's going to be 2i plus 3. Number 22, perform the operation and write the result in standard form. So we have 3 minus 2i over 2 plus 4i. We have to multiply by the complex conjugate, which is simply changing the middle sign of our denominator. Then we're going to FOIL the top. So we're going to get 6 minus 12i minus 4i plus 8i squared. The denominator will always FOIL to a difference of squares. So this is going to be 2 squared minus 4i squared. Now we can combine like terms. We have this negative 12i and this negative 4i. Then we also have I squared. Just a reminder that when we're working on the denominator, I actually need to adjust one thing. This squared should be on the outside. When we're working on the denominator, this squared applies to both the 4 and the I. I've had a lot of students make mistakes there. So we have 6 minus 16i plus 8 times negative 1 because I is negative 1. I squared is negative 1. In the denominator, 2 squared is 4. 4 squared is 16. And then we're going to have I squared again. Okay, and that's also going to be negative 1 down there. Okay, so we're going to have in the numerator 6 minus 8. That's going to be negative 2 plus 16i. In the denominator, we'll have 4 minus 16 times negative 1. And that's going to be 20. Now, all of these numbers are divisible by 2, so we can go ahead and divide them by 2. And it's also more appropriate to write our real numbers separately from our imaginary numbers. So I'm going to do both of those things. Our real portion can simplify by 2, and it actually looks like our imaginary portion can simplify by 4. So this is our final answer. Number 23, simplify 4 plus 3i times the quantity negative 3 plus 2i. We're going to FOIL this. So we'll have 4 times negative 3, that's negative 12. 4 times 2i, that's going to be 8i. 3i times negative 3, that's going to be negative 9i. And lastly, 3i times 2i, and that's going to be 6i squared. Negative 12 minus 1i plus 6 times negative 1. Okay, because remember, I squared is negative 1. So negative 12 minus 6 is negative 18. Then we have negative 1i. We don't really have to write the 1 there, so it's just negative 18 minus I. Number 24, find the vertex form of the parabola. This is going to involve completing the square. So in order to start completing the square, we do have to have a 1 as the coefficient of our x squared, which means that we do need to factor out a negative 2 from this expression. Now we're going to insert a blank inside of our parentheses, and I'll explain why in just a second. Then we're also going to have minus a negative 2 times that same blank. Okay, and I will explain everything that's going on here in just a second. When we complete the square, we are going to input the value here, and that's going to be b over 2 squared. Our b value is coming from our middle term in front of our x value, which is going to be negative 2 over 2 squared, which is just 1. Now, the reason why we have to do this over here. When we are adding something to this side, we also need to take care of it and do the opposite the inverse operation over here so that we don't change the value. If we were to distribute this 2 in, it would be a -2. That's why I have these two negatives out here, because we are subtracting a -2 times 1. So this would become a positive. This is a negative, so we're not changing the value of the equation. We are simply rewriting it in a way that is more easily identifiable for the vertex. Now, this right here is a perfect square trinomial, and that is going to factor like this. Then over here, we have -5 plus 2, and that's going to be -3. So this is the vertex form of our parabola. It's a little bit tricky at first, and I'm happy to do another lesson if you guys need more help with completing the square. Simply let me know in the comments. I'm happy to do another video. Number 25, here's some mixed review. How many roots and what type does the following function have? This is the discriminant formula. So what we need to do is get this set equal to 0 and then fill in our discriminant. So I'm going to subtract x and subtract 3. So we're going to get 0 equals 3x squared minus x minus 3. Now our discriminant formula is b squared minus 4ac. And there are 3 conditions to be able to tell what our roots will be, and we'll address that in a second. Our b value here is -1, our a value is 3, and our c value is -3. So 1 plus 12 times 3 is 36, and that's going to be 37 for our discriminant. Since our discriminant is greater than 0, that means that we're going to have 2 real solutions. The other 2 conditions for the discriminant is if it equals 0, there will be 1 real solution, and if it is less than 0, there will be 0 real solutions or 2 imaginary solutions. Number 26, write an equation for the function shown in the graph and its absolute value. So remember that our parent function looks like this. Start at the origin, and you're going to go up 1 over 1. Okay, so this is what our parent function looks like. Now our blue graph looks significantly changed. Okay, definitely an adjustment. I'm trying to make that straight, it's not working, but it's supposed to be straight. Now we can see that our graph is definitely flipped over, and our graph is also more narrow than what the parent function is. It's also translated. So let's look at the vertex and figure out our horizontal and vertical translations first. Our vertex was at the origin, and it is now at -1, 3. That means that we went left 1 and up 3. Just going to make that note there. Now, our parent function is also at 0, 1, 1, -1, 1. It is now, so this is like basically over and up. Now, from here, we're going down 3 and over 1. So our values are being stretched by 3. You may recall that our format of an absolute value function looks like this, where a is our stretch and it's also our reflection. Okay, if it's negative, it's a reflection. I forgot to write that down, but reflect over x. Okay, then our horizontal translation goes inside the grouping symbols, and if we're going left, it's going to be a plus there. Then our y value for our vertex is going to go where k is. So this is going to be the equation of our line. Number 27, write an inequality that best describes the graph shown. We can tell right off the bat that it's going to be y is greater than or equal to, so this is a solid line, and we are shading above the y-axis here, where the intercept is, above the y-intercept. So this is going to be y is greater than or equal to, the parent function here is a parabola, so it's going to be some sort of x squared. Now, this actually has no stretch or compression because our original function, if you recall, looks like this. 0, 0, 1, 1, negative 1, 1. And if I were to graph this, and if I were to trace it on top of each other, it would fit exactly. So there's no stretch or compression. So that means that A is 1. We do, however, have a horizontal translation to the right 1 and down 4, which means that this is what our equation is going to look like. Number 28, solve x squared plus 10x plus 29 equals 0. This is not going to factor because 29 is a prime number, so there are no factors of 29 that will add to 10, which means that we could either complete the square or do the quadratic formula. I'm going to go ahead and do the quadratic formula here. Our b value is going to come from the number in front of x. The a value is the number in front of x squared. And lastly, our c value comes from our constant term. So the x value for the solution is going to be negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 29. And that entire thing is over 2 times 1. So here we're going to have negative 10 plus or minus the square root of 100 minus 29 times 4. It's going to be 116 over 2. Simplifying this a little further is going to be the square root of negative 16 over 2. When we have a negative underneath our square root, that means that we are going to have some imaginary numbers. So this is going to be negative 10 plus or minus 4i over 2. So I'll break that down a little bit to make sure that you understand that. This is going to be the square root of negative 1 times the square root of 16. The square root of negative 1 is I, and the square root of 16 is 4. That's how we're getting this value right here. Now both 10 and negative 10 and 4 are divisible by 2, so we can go ahead and divide those. Negative 10 divided by 2 is negative 5, and 4 divided by 2 is 2. So x equals negative 5 plus or minus 2i. Those are the solutions to the equation. Number 29, describe the nature of the roots. 4x squared minus 4x minus 6 equals 0. Remember that in order to find the roots, we're going to do the discriminant here. Our b value is negative 4. Our a value is 4, and our c value is negative 6. So we're going to have 16 plus 96. Okay. And that value, that answer is going to be 112. Anytime that we have a discriminant that is greater than 0, we are going to have two real solutions. Number 30, 6 plus 4i plus negative 4 minus 5i. We are simply going to combine like terms here, 6 and negative 4, and 4i and negative 5i. That's going to be 2 minus I. And that's our answer. Number 31. We have the quantity negative 5 minus 6i times 5 minus 3i. We're going to FOIL this. So we're going to get negative 25 plus 15i minus 30i plus 18i squared. Combining like terms is going to yield negative 25 minus 15i plus 18 times negative 1, because remember that I squared is negative 1. So negative 25 minus 18 will be negative 43 minus 15i. And that's our final answer. Divide 4 minus 3i by 2 plus 3i. This is another example of having to multiply by the complex conjugate. And again, just a reminder, that's where we take the opposite sign of our denominator and multiply both top and bottom by that. Just a reminder why this works. This number is a 1. So we're not changing the value of our equation, of our expression. We are just simply rewriting it in a different format. So we're going to FOIL the numerator, and that's going to be 8 minus 12i minus 6i plus 9i squared. And as I mentioned before, our denominator will always FOIL to a difference of squares. So we have 2 squared minus 3i squared. Combining like terms will get us 8 minus 18i plus 9 times negative 1. Okay, now in the denominator we'll have 4 minus 9i squared. Just a reminder, I squared is negative 1. So 8 minus 9 is going to be negative 1. Then you have negative 18i. Now we have 4 minus 9 times negative 1. Negative 1 minus 18i over 4 plus 9 is going to be 13. And then to write this in the proper format, we do need to separate our real and our imaginary parts. So this is our final answer. Number 34, write the equation in standard form. The only part that is not in standard form right now is this fraction, and we need to move our y. Well, in order to get rid of the fraction, we can simply multiply the entire equation by 5. By doing that, we're going to get rid of this denominator and be one step closer to getting us into standard form. Now we need to move our 20y onto the other side. So the final answer is going to be 2x minus 20y equals negative 20. Remember that standard form is in ax plus by equals c format. Okay, so this is our final answer here. The only other thing that you could do here is divide everything by 2. So the more simple form would look like this. And that's the answer I would go with. Number 35, write the slope-intercept form of the line passing through negative 2, 1 and parallel to y equals 5x plus 3. The only thing that we have to extract from this equation here is our slope. So we're going to go ahead and pull out that 5. And our slope that's parallel to that is going to also be 5. The rest of that equation is now irrelevant. We want the slope-intercept form, so we're going to write y equals mx plus b. Our parallel slope is going to be 5, and then we can use negative 2 for our x and 1 for our y. So now solving for our y-intercept, this is what this is going to look like. So our b is 11. Now writing our final answer is going to be y equals mx plus b, where our slope is 5 and our b is 11. So this equation is um, the line that has a slope that's the same as the one that we were given, and the line is parallel. The line that we found is parallel to the one that we were given. Number 36, what factorization can be used to find the zeros of f of x equals x squared plus 25? Well, in this case, this is a little bit of a trick answer because there are going to be no zeros here. If we were to subtract 25 from both sides, we would run into a little bit of an issue here because if we go to take the square root of negative 25, we're going to get imaginary answers. So this one is not possible. Number 37, solve x squared plus 2 equals 6x. So the first thing I'm going to do is move 6x on the other side and get this set equal to 0. I can already tell that this is not going to factor because we would have to look for factors of 2 that add to negative 6, and those don't exist. So this is looking like another quadratic formula problem. So let's go ahead and replace all of our values with the values in the equation. Okay, after further simplifying, negative times a negative is a positive, so we'll have positive 6 plus or minus the square root of negative 6 squared is positive 36. 4 times 2 times 1 is going to be 8. Then we're going to divide that answer by 2. So we're going to get x equals 6 plus or minus the square root of 24. Let's see, 28 over 2. Now the square root of 28 can simplify a little bit. If we break that down into 4 and 7, and then 2 and 2, so this is going to reduce to 2 square root 7. Both 6 and 2 are both divisible by 2, so we can go ahead and write it that way. And these are our two solutions to the equation. Number 38, write as a complex number in standard form. This is another complex conjugate that we will need to multiply. So let's FOIL the top. We're going to get 16 plus 24i minus 20i minus 30i squared. And again, the denominator will always factor to a difference of squares. So let's simplify the numerator. We're going to get 16 plus 4i minus 30 times negative 1, and that's going to be over 16 minus 36i squared. So now we're going to get 16, okay, plus 30, that's going to be 46, plus 4i. And then in the denominator, remember that this is going to be negative 1, so we're also going to have 16 plus 36, and that's going to be 52. Now we can simplify this a little bit. So we have 46 over 52 plus 4 over 52i. And the simplest form of that will be, we can divide 46 over 52 by 2 to get 23 over 26. And then we can divide 4 and 52 both by 4. And that'll be 1 over 13i. Standard form, by the way, of a complex number is just in a plus bi format, and we have accomplished that. This is the real part, this is our b, and then we have our I there. Number 39, which function models the path of a ball that lands 3 seconds after it was thrown upward? So there's something that all of these options have in common, and that is this first number out here. That's the factor that gravity has. So all of those are going to include -16. Now, in order to figure out which one actually works, the height of our ball is going to be on the ground. It's going to be 0. So what we have to figure out is when we plug in 3 for x, which one is going to give us the result of 0. So this one we're just going to plug into the calculator and figure out which value that is. And when we do that, we are going to see that this second option here does give us 0. So if you've made it all the way through with me, congratulations. I hope that you do super well on your final or your midterms this week. And we'll see you next time. Make sure that you click the subscribe button below and let me know if there's anything else you'd like me to cover.